Assalamualaikum and very good day to all of you. So how are you everyone?
Alhamdulillah, good doktor.
Good.
Okay, Alhamdulillah. Okay, so today basically this is our final class. However, we need to cover 3 more topics. Okay, we will try to finish these 3 topics depending on our time today. Okay, so basically today for the morning session we will cover on project time cost trade-off, or we can just simply call it as project crashing. So for this topic I will cover the both fundamental and also calculation parts. Okay, for your information, this is also one of the important topic, especially for your final assessment. All right, and the other topics are project. Sorry, the other 2 topics we will cover on project monitoring and controlling, and then the final one will be project delay analysis. Okay, so without further delay, let me take to our today's topic. Right. So as usual, this is our checklist for the topics that we need to cover. So previously we have covered on these 3 topics of project resource planning and also project cost planning, which is divided into 2 parts, part 1 and also part 2. So I hope all of you have so far all of you can understand all of these topic, and then we will proceed to this third topic, I think, project time cost trade-off, which is project crashing. And then we have project monitoring and controlling. And the last one will be project delay analysis. Okay. So regarding assessment, basically we have done this quiz 1 for 5% for your carry mark, and then we have basically for assessment, except for final exam, we have 30 marks here for your carry mark. So far we have covered 5%. Maybe the rest of 25% we will cover for either for individual assignment and group project, or individual assignment with the test, maybe test 2. Okay. So that one I will confirm later and then update the any changes through WhatsApp group or e-learning. Okay. So let us proceed to this lecture. Okay, so basically this is our topic outlines, which is consists of several subtopics. So basically first the few topics cover on theoretical part, which is mostly on the introduction and the overview of what's actually project crashing is. And then I will cover on several related theoretical part. And before we end our morning session, we will cover on the calculation part, which is how we do the project crashing, what are the related sequence that we need to follow. And then we will, as usual, we will cover on several sample questions. Okay, we try to prepare the related calculation to answer this project crashing questions. Okay, so first of all, regarding the introduction or overview of project crashing. Alright, so we will cover on the definition of project crashing, or basically it is called as time cost trade-off. However, it is easier for us to refer it as project crashing. Beside crashing, we can call it by several other names such as compression, because compression refers to how we compress the project in order for us to achieve a specific aim, specific objective in terms of to reduce the time and also to increase the resources. Okay. Besides that, we also call it as expediting and also shortening. Okay, all of these name refers to the same what we call same item, however with different names or different terms. Okay, so basically project crashing refer to the project shortening, meaning that we need to shorten the project duration by reducing the time of one or more activities. So meaning that this statement refers to how we reduce and how we select uh, the suitable activities to be shortened in order for us to have a compressed project duration, and in order to make sure that the contractor able to deliver that specific activities within the limited time depending on the situation. Okay, so the main item here is that we need to reduce the time, and at the same time we need to increase the resources, either in terms, basically in terms of manpower, labor itself. Okay, because manpower is the main resources of any construction project or any other project. Okay, so basically that's the general definition of project crashing. All right, so okay, basically this is just an example of fast track construction project. So basically this is just for you to have what we call overview on how a construction project has been crashed in terms of times and also increasing the resources. All right. Okay, seems that it's not working here. It's okay. Later on, I will share this video to all of you. Together with the lecture notes, I will upload this video. All right. It's okay. Okay, and then basically, just to recall our previous lecture. All right. Basically, this information or this basic, sorry. Okay, this basic formula or equation is very important even for this topic, because we need always to remember that contract or project value is equal to total cost plus profit. So by right, so far I think all of you already familiar and can remember this simple formula. And because you need to apply this, you need to remember this for you to use during the previous topic of project cash flow and also for this topic. Okay, so similarly for this one, just a revision. Total cost, which is contribute to 100% of the cost of the project cost, which is the breakdown of direct cost and also indirect cost. So basically, direct cost, as the name it is, it refers to the major cost of any project, which is contributes for about 90% of the total cost. So the other cost, which is indirect cost, it's only contribute for about 10%. So the total will be 100%. Okay. And then we have, okay, basically that's all regarding the introduction or overview for the project crashing. Okay, the next subtopic we will cover on relationship between time and cost, because today's topic is about project time cost trade-off. So that's why we need to understand this part of theoretical and also its fundamental part. Okay. Okay, so basically this is a conceptual graph in order for us to understand the relationship of both components of time and cost. All right, so basically this is cost versus time. Basically for this example, we have yearly basis here. Maybe here we have year 1, 2, 3, and so on. Okay. So basically this is depending on the scale of the project. So it can be in monthly or maybe weekly basis. However, this is just for the example, it is on annual basis. All right. So what we have here is that if we can see there are three lines of different, what we call different, which is to represent the different costs. Okay, the first one we have the total cost. So here we have the inverted curve for representing this what we call the total cost. And then similarly for direct cost, the curve is just quite similar to the total cost. And then we have indirect cost. So basically for the indirect cost, we have a directly proportional line with the cost versus time. And then what we have here is that if we can see, previously I also explained regarding this relationship actually, because as you can see, the what we call the shape of the graph for total cost is similar to the direct cost, because direct cost is the only cost that contribute the most to the total cost. So that's why at the end we have this kind of curve, which is this one. Okay, in order to represent the total cost. Okay, so indirect cost is just around 10%. So that's why it not really contribute to the total cost. Instead, this direct cost is about 90%. Okay, so another thing is that based on this, what we call based on this graph, we have the optimum cost for us to do the project crashing and also project compression. So basically, we need to do an optimum project crashing. So later on, the contractor will have a balanced achievement in terms of cost and also the time. So that's why we need to do an optimum project crashing or project compression. So later on, I will explain more on this. So basically, this is just a conceptual graph. So as we can see here that, okay, for example here from 0, the time or the duration is 0. And here we have year 1, for example here, year 1. Okay, as we can see here that, if we try to, if we try to compress and also to crash that project, basically the specific project, for example, okay, here we have cost, for example, 10,000. However, throughout the time, if we try to reduce the time, okay, the cost will decrease as the time increase. Okay, So this is the relationship. However, at certain time, which is this optimum cost point, meaning that the border or the limit. So here we have this dotted line represent the borderline for the project compression. So at certain point there is a limit where if we try to compress more, the cost maybe increase. So that's the point of this conceptual graph in order to visualize that it visualize in terms of we can compress that project meaning that totally crash that project, that specific activities, because at certain point we will bear the cost, we will bear the loss because it will consume more cost instead of we try to optimize the cost and time. Okay, so later on I will show you the detailed relationship between these two components, time and cost. All right, so the next one we have this one. All right, okay, this is basically related to previous graph. Okay, as we can see here, we have time, whether it is increase, decrease, and we also have this what we call this type of cost, which are direct, indirect, and also total cost. Okay, for example, if we try to increase the time, okay, it can be in three situations, whether the cost, all of these costs can increase. Okay, this is the first situation. And the other situation is that we try to compress the time. However, most of the time direct costs will for sure will increase. However, for certain case, indirect costs can decrease and it is just the same for total cost. Okay, as we can see here, direct cost is directly related to the total cost. Okay, since it contribute the most to the percentage of the total cost. Okay, for the first one here we have direct cost. There are several reasons actually for this situation. If we try to increase the time for the direct cost, so basically the reason is that if we try to increase this time for direct cost, if we try to increase the time, direct cost will be efficient use of resources as time increase. Okay, so basically in terms of resources, there will be certain point where we will have the efficient use of resources as the time increase. However, we can utilize that specific resources too much, because at certain time it will leads to project loss, especially in terms of the cost. All right, and then the other thing is that increase of resources as time decrease. Okay, so the resources sometimes should be increased in order for us to decrease the time. So meaning that we need to utilize more resources in order for us to compress that specific activities or works that need to be delivered. Okay, for example here, we can employ more labor, and also we can utilize more machineries which is to be worked concurrently in order for the contractor to have to have shorter time to deliver that specific activities. Okay, so all of these are interrelated, especially between the time and also the cost. So all of these are depending on the choice and the decision by the contractor, okay, or by the project planner. Okay, so the other thing is that indirect cost. So basically it is proportional with the time. So if the cost increase, the time will be decreased. Okay, so it is also may become less as time decrease, and it is can be vice versa. All right, it can be decrease or increase. All right. So the other one is total cost. Practically, it may increase as the direct cost increases. Okay, because total cost is directly related to the direct cost. All right. So basically, all of this just a conceptual part or theoretical part of this to this topic. Okay. So far, I hope all of you can grab this idea of time cost relationship. Okay, is it okay, everyone?
Okay, cuma kalau I boleh tambah,
Okay,
basically on the direct cost ni is purely depend on the contract type.
okay,
So if our contract is lump sum contract, so I
okay.
think even the time is increase or decrease,
Mm-hmm.
the direct cost is the same, unless the direct cost, the contract is unit rate. Then when the time is increased, then the direct cost will increase lah. But on the direct cost, in the indirect cost, basically is manpower cost. The relationship is right lah. When the time increase,
Mm-hmm.
definitely the PMT, PMC cost will increase. But
Okay.
for the direct cost, it depend on the contract type. Either
Oh,
it's a lump sum or unit rate or others lah.
conventional, right? Okay. So, thank you, siapa tadi? Encik Iskandar. Alright. So basically, as mentioned by Encik Iskandar, direct cost basically depending on the type of contract, right? Encik Iskandar.
Yeah, je.
Okay. So, as we know, because we already have currently, especially currently, we have so many types of what we call uh, types of contract. So basically, for the purpose of this topic, we try to refer to the conventional one or to the common contract type. Okay.
So
How?
kalau conventional is lump sum lah kan?
Ha.
So kalau lump sum, kalau kita masa kita panjang ke atau masa kita pendek ke, the contract value saya sama.
Okay. So basically, dia kejap.
Katalah macam kontrak tu harga dia RM100, kena siap
Mhm.
dalam seminggu. Dia
Mhm.
siap 10 hari pun still RM10, dia siap 3 hari pun still RM10 je lah dia.
Sebab dia dah apa
Lump
lamsam kan?
sum, iya.
Okay. Alright. So basically apa ni? Tapi dia punya apa nak cakap dia punya main konsep lah. Dia memang once kita dah apa? Kita dah increase the time, kita dah cuba compress the time sebab kita kena utilize ataupun kita kena guna lebih resources. So basically cost tu akan meningkat lah. Okay. So that's the ni lah dia punya macam apa rule of thumb lah juga kan. Okay. So okay semua? Before we proceed to the next one. Okay. So later on, if you have anything to add or anything to ask, you can just kira terus tanyalah, terus bincang kat sini. Okay, any inputs very apa orang kata, sangat ni lah, kita boleh sama-sama dapat apa, new input and then sama-sama share lah kat sini. Okay, and then we still on the theoretical or fundamental parts. So we have covered on this overview for the project crashing and also the relationship just now. And then okay, basically we will cover on the reasons ataupun dia punya apa, purpose of why we do the project crashing. Okay. So basically for the reason actually there are several other reasons because this one is just several example of the purpose why we do the project compression or project crashing. Okay. Before that, I would like to ask any of you, ada siapa-siapa ke yang pernah handle in terms of this project compression or project crashing? Anyone who have experience regarding this project compression? Either directly manage that what we call that crashing part or just do the checking. Anyone? Ada ke yang pernah involved with this? Maksudnya untuk previous project that have this kind of project crashing.
Kalau part saya, I start from client. So we just order the contractor to crashing back the schedule, the work program. Because of crashing ni, kita tak bagi EOT kan doktor. So it's not impact to the tarikh siap sebenar. Tapi because of the project is quite delay, so without EOT, we order contractor to crashing back the work program. So itu biasa berlaku lah.
Okay, so basically macam sebab apa tadi Diana part on apa orang panggil site client side kan?
Client, yes.
So basically apa part Diana akan more on checking lah that revise
Betul.
or crash ni schedule tu kan?
Betul.
Okay, so basically dia just a minor minor crashing je lah, minor compression.
Yes,
for
betul.
critical activities, right?
Dia still dalam value contract yang sama and time yang sama. Just untuk crashing lah. Kalau untuk reverse baru dia akan berubah melibatkan penambahan VO ataupun time. Perubahan time.
Okay, thank you. Siapa tadi Diana?
Yeah.
Alright. So basically Diana previously has in charge on sebab Diana from client side. So basically more on approval and checking that crashing activities lah of the related schedule. Okay. So apart from that, macam siapa lagi yang from construction ataupun ada background? Siapa? We have Awin, Iskan, Mr. Tai, Salim. We have total 7 of you, right? Okay, Maika pun tak pernah Maika?
Never, tak pernah.
Oh, okay, it's okay. Alright, so basically so far that's dia punya main purpose ataupun main ni lah gist of that project crashing. So hopefully all of you can understand that what we call the main dia punya overview lah for that project crashing. So basically continue back to this reasons of project crashing or purpose why we do the crashing or compression. Okay, so basically there are several other detailed reasons and for sure we have what we call related reference focusing on this project crashing. However, for this slide, I will share just a few main keywords lah, dia punya main reasons for the project crashing. Okay, so basically the first one is regarding the bonus or advantages. So basically, sometimes there is a need for the contractor to crash or to compress specific activities or specific work to be delivered, because it is depending on the client request. Okay. So once the client requests the project to be completed ahead of actual scheduled time, so the contractor we need to do so, so they can try to do the project crashing. Okay. At the same time, they can submit, as mentioned by Diana just now. They need to submit the crash schedule that have been prepared. Okay, so that once they have prepared the crashing, the new schedule or any changes to that schedule will be submitted to the client for the approval. Okay, so by having this project crashing, the client will need to deliver the project within a shorter time, which is ahead of actual schedule time. Okay, and then basically what we call the first reason is depending on the request, okay, by the client. Okay, for example, it can be for example residential housing, housing project. For example, as we know, for the housing project, we have several phases. Okay, several phase, maybe phase 1, phase 2, and so on. Okay, maybe in certain case, the client may request the contractor, okay, depending on the situation, where the contractor need to speed up the delivery. So in order for the contractor to deliver that specific phase of the construction, so they need to do this project crashing of the related activities. Okay, so later on we will go through some examples of how we do the crashing. All right. And then the other reason is that regarding the penalties. So basically, penalties are common for the delay issues. All right. So any delay of earlier activities of the previous activities may force the contractor to reduce the remaining time in order to meet the actual scheduled time. Okay. So most of the time, contractor will compress, will crash the potential activities if they face any delay issues. Okay, because as we know, delay issues is quite common because it depending on various factor, either as I think we have covered also previously, delay can be due to the lack of resources. Okay, resources are quite what we call, can be divided into several sub reasons, sub factor, because resources can be labor, materials and machineries and so on. So that will contribute to the delay of the activities that need to be done by the contractor in order to deliver that specific activity to the client. Okay. Okay, the other reason it can be that the contractor try to crash the specific activity or try to compress activity due to they want to freeing the resources. So most of the time this is because maybe the contractor got the opportunity of new project which is required them to move out the resources to new site. So this one basically for the case where the contractor to obtain able to obtain new project during the construction of the existing project. So maybe at the end of the previous project, they have been awarded with the other project, so they try to manage their resources. So that's why they try to do the crashing in order for them to freeing these related resources. Okay, so the next one is regarding the seasonal consideration. So basically, for the seasonal consideration, it's depending on the weather itself, weather condition. Okay, because as we know, bad weather condition will also affect the progress of work. So by referring to the weather forecast of the potential adverse weather conditions such as heavy raining and also flooding. So by having this forecast, or by having the prior information regarding the seasonal situation or condition, they can plan or they can manage to do the project crashing, so that they can avoid this bad weather condition. Okay, because during the severe weather condition, it will affect the what we call the progress of work. So they try to arrange, they try to plan their works, and if they have at certain time, if they have too much activities or too much works to be delivered, okay, that's why they need to apply this project crashing activities. Okay, by having this project crashing, they will manage to reduce the time of the project delivery, okay, or project completion. Oh, sorry. Okay. Another thing is that it's related to the impacts. So basically, error in purchasing excessive materials for the contractor to reduce time to avoid wastage and also negative cash flow. So basically, crashing of the works or activities also will be done if there are errors in purchasing excessive materials. Okay, for example, as we know, there should not be excessive material on site, because at certain time, at certain point, that excessive material can be a wastage. Okay, so that wastage will lead to the negative cash flow. So in order for the contractor to avoid this situation, they can consider this project compression. So they try to allocate the excessive material, for example, what we call cement and so on. Okay, they can try to utilize that extra materials to do to the related works or related activities. So they can have the concurrent activities in order for them to crash the time of project completion of specific activities. Okay, so overall, these are the reasons of project crashing. However, for the rest of the reason, maybe we have the sub-factor and so on. Okay, we can try to explore by our own. Okay, we can have you can have your own reading if you try to obtain more in detail regarding this project crashing. Okay, so in general, that's the overview for the project crashing purpose, or the reason of why we need the project crashing. All right. And then the next one is that regarding the ways or methods to shorten the project time. Okay. As I mentioned earlier, the main purpose of project crashing or project compression, it's all about the how we shorten the project duration in order for the contractor or the respected parties to deliver the works within the specified time. Okay, especially in case of delay issues. All right. Okay. Basically, there are what we call two main methods or two main alternative that can be used to shorten the project time. Okay, the first one we have resequencing activities, and then we have accelerating activities. All right, for the first one, in order for us to resequencing the activities is basically referring to the how we arrange the related activities. Okay, because the other thing is that constraint can eliminate coordination problem. Okay, so we try to eliminate any related problems, so that by having the resequencing or rearranging the activities, we should ensure that there is no any coordination problem. All right. So by having this what we call this planning or this management of project, in order for us to crash that project, so later on there will no issues regarding the what we call regarding the related potential problems, such as lack of resources and so on, because that one at the end will still contribute to the delay. All right. Resequencing activities, if it is unnecessarily delay project completion. Okay. So meaning that at the end we try to eliminate any delay, we try to reduce the delay. So even though we try to shorten the project duration, we need to consider both time and cost in terms of resources and so on. So that's why it should be avoided unless essential. Okay, this rearranging activities. Okay, if we want to do the crashing, unless it is very essential or it's very required to do so, we can rearrange the activities. If not, we try to do the accelerating. We try to accelerate the activities. Maybe we can do the concurrent work and so on. Okay, because as we know, schedule cost is usually optimum or minimum. So sometimes it may increase the cost because we need to utilize more resources at certain time. Okay. So it's really feasible to completely crash the activities. All right. I think I already mentioned this one. It is impossible for us to completely crash the certain activities. Okay. We can just try to crash or try to compress specific activities, maybe half of the project duration. All right. And the other thing is that we try to shorten the project at the least cost. Okay, we need to try to balance both components in terms of time and also in terms of cost. Okay. That's the way to shorten the project time. Okay. The next one, I think. Okay. Okay, continue to this what I call to this subtopic of ways to shorten project time. So basically, how we want to crash certain activities or certain works. related to the total completion duration. Okay, so basically if we want to do the project shortening or project crashing, we can try to manage, or we can try to plan on the resources. So basically here we have three main resources. The first one we have manpower. All right. Okay, as I mentioned in our previous class, there are there are several main resources of any project. So basically it refers to 5M. All right. So the first one will be manpower, and then we have machinery or plant, or sometimes it's also called as equipment, plant and machinery, and also equipment. And then we have this one, material. Okay, any related material for the specific work. Okay, for example, concreting work, we need the basic material of water, of sand, water, and also cement. Okay, so that's the basic one for the material. And then the other two for this 5M are methods and also money. So methods basically refers to the how the contractor construct the works in terms of the technical performance. Okay, back to this one, how to crash the activities. Okay, for the first one, manpower. In order for the contractor to reduce or to shorten the time, the project time, they can try to employ extra manpower for each activity. Okay, so basically, for sure, obviously, for this one, it will, affect the cost, because extra manpower require extra payment. So that's why it may affect the cost. Okay. And then we can have we can propose a plan for multiple working shift among the labor or manpower. So all of these are related to the still related to the resource management. Okay, the project planner or anyone who are in charge is management part, or the planning part, they can try to use or try to utilize the potential alternative in order for them to crash specific activities. Okay, the first one is related to manpower. So they can add more numbers of the labor itself for the specific activities. And then they can use multiple working shift. And the other thing is that they can extend the working hours. So it's depending on the situation itself, whether which of these option that they want to use in order for them to reduce the completion time of the specific activities. All right. Okay. Similarly to the machinery. Okay. In order for them to crash the activities, so they need more, what we call more quantity or more numbers of machinery or plant. Okay, so basically they will need additional equipment to support the what we call support the certain activities that need to be completed in a shorter duration. Okay, so if later on I will share the previous fast track project, construction project. So basically, if we look at to that what we call to that video, it can be seen that they employ or they utilize more resources, especially in terms of machinery. Okay, because actually that project is about the high-rise building. If I'm not mistaken, it is a accommodation building. which is hotel, if I'm not mistaken. So they have utilized more resources in terms of larger or giant plant and machineries, especially the mobile crane and also the tower crane, okay, at the construction site, in order for them to do the crash. Okay, so at the end, they can deliver the project in a shorter duration. Okay, that's how they employ the extra plant and machinery. Okay, and then regarding the material, so basically more cost, if we utilize more resources, so for sure it is more costly. However, it can be more quickly installed material. So basically, this what we call this are related to the or referring to the, for example, IBS system. Okay, so we have a precast building component. So basically, all of these component that have been casted at the manufacturer site, being brought to the construction site, they can just install that specific component within a shorter duration. However, most of the time, it is quite costly as compared to the conventional construction. Okay, so all of these are depending on the decision and choice by the contractor themselves, or also the anyone who are related, such as project planner or project manager. Okay. Okay. Continue to the ways to shorten the project time. So basically, this is just an example of how the time and cost are related. Okay. So as we can see here that this is the example to install the metal siding. So basically, based on this given table, there are several estimated daily production in meter square. Okay, so this is the specific area that need to be completed, which is estimated what we call estimated quantity. And then the second column shows the crew size to install that metal siding. Okay, so basically here it's already given that if they have a crew size A, which consists of one scaffolding, two laborers, one carpenter, and one carpenter foreman. So basically with this quantity and also the capacity of this crew size, they are only able to cover this area. Okay, the production area. Okay, at the end, they can cover this 120 meters square for that specific metal siding works. Okay. However, if we try to increase the size of that crew, okay, for example here, as compare crew size A and B, okay, this one B, we have extra carpenter here. So by having extra resources, especially the manpower or the labor, for sure this estimated daily production will be increased. So meaning that by having more production rate, so for sure the time the specific activities will be shortened or will be increased. Okay, so if we look at to the rest of this crew size, as the crew size increase, the estimated daily production for sure also increase. Okay, for this situation, the time to complete this project or to complete these activities will decrease depending on the crew size especially the resources in terms of manpower. Okay, how about the cost? So basically here we have, this is just the simple sample for the purpose of project shortening by considering the time and cost. So basically, this is the cost rate for each, what we call for each manpower. Okay, for example, scaffolding, we have 60 ringgit per day. Laborer, we have rate per hour, also per hour, which basically they will work about 8 hours per day. All right. And similarly to the carpenter and also carpenter foreman. All right. So what we have here is that based on the total area of 7,700 meters square, what is the duration for installing this metal siding? All right. What we can do here is that we just we just calculate this total area to be covered, and for example here, if we choose the crew size A, so the estimated daily production is about 120 meter square per day, and then we will obtain this what we call this estimated duration or estimated time to complete these specific activities to install the metal siding. Right, so this is basically the time or the duration. Here we have duration. Okay, so next one, continue to this. Okay, so basically, okay, before that, is it okay, everyone? So far, can you understand all of this?
Yes, okay, doctor.
Is everything good?
Yeah, so
All
far so
right.
good.
Okay, thank you. Pardon? Dia macam terputus tadi. Macam mana? Okay, eh? I'm afraid that suddenly we have some connection issues or lagging. Okay. Okay, if there is no any technical issues, so hopefully all of us can understand this. All right. Okay, continue to this. We have the next table. All right. So basically, this second table is just what we call to summarize the previous calculation lah. For example here, because previously we have 4 types of crew size. Okay, we have A, B, C, and D. So basically, we try to calculate all of the option. Okay, if we employ the crew size A, what happened and what's actual the duration and also the cost. All right. So basically, for example, here we have crew size A, okay, as being calculated before this. Here, just put all the what we call all the output or all the data to this table. So actual duration is 64.2. So we need to run off because it is day duration. We should have the whole number. Okay. So it's about 65 days. And then in terms of cost, okay, how we calculate the cost, later on I will show for this calculation. So if we do both calculation to calculate the related or required days and also what are the associated costs, what is the total cost required, and then we can do the comparison. Okay. Okay, for example, the daily cost for crew size A, okay, we need to include all of the related manpower for that specific crew size. For example, if we refer back to this table, crew size A consists of 1 scaffolding, 2 laborers, 1 carpenter, and 1 foreman. Okay, then refer back to the cost rate for each of the manpower. Okay, so we just times the number of that specific manpower with its working rate. Okay, and at the end we will have this, what we call, we will have this amount for each manpower, and at the end we can have the total daily cost. Okay, so basically for this sample question, the total daily cost of crew size A is about 364 ringgit. Okay, and then we need to divide by days because and we need to times with the total duration of the days. Okay, so at the end we will have the total direct cost here. Okay, so this amount is just the same to this one. Okay, in order for the purpose of what we call for the purpose of project shortening or project compression, we try to select the most optimum option so that they can have a balance between the time and the cost. Okay. So continue to the rest of the crew size. So as we can see here that if we do the comparison, B is the most optimum, what we call optimum choice because in terms of duration, the duration it's about 51 days. Okay, it's still higher, it's still shorter than the first what we call shorter for about 14 days as compared to the crew size crew size A. Okay, however it is slightly longer than if they utilize the crew size C and D. Okay, if you can see here that if they try to crash more or they try to use extra manpower, so for sure the what we call the duration will be decreased. However, we need to look at also to the cost. Okay, so far as we can see from the crew size A to B, there will be decrease in terms of cost. However, if they utilize more number of crew size, the cost at certain point will increase. Okay, from B to C, there will be increase in terms of cost. Okay, which is quite similar to the option crew size D. Okay, if we refer back, both of these costs are higher than if we hire the crew size A. Okay, so that's all how we choose the optimum one. Okay, so if we can relate back to the previous graph, we have the middle line for the optimum choice. Okay, at certain point, the cost will increase. Okay, and then the next one. Okay, so basically this is just a plotting for the previous one to show the what I have mentioned just now, to show this optimum choice. Okay, so basically 2264 is referring to the crew size A. Okay, so that's basically by having all of this calculation and analysis, we can choose the most optimum option. Okay, in this case, we will go for crew size B. This one, crew size B, for the optimum choice to carry out the specific work, in this case to install the metal siding. Okay, so basically this is overview not the view, the what we call the view of how we do the analysis and try to select the optimum choice. Okay. All right. So that's regarding the ways to shorten project duration. The next one is that, sorry, assumption of project crashing. So I think before we have some break later on, because I have a short break, I will continue to one more subtopic, which is assumption of project crashing. So basically this assumption will also need us to do the calculation. Okay. So I will continue to the assumption of project crashing. Let me check the slide first. Okay, because this assumption of project crashing is basically related to the we need to do the calculation also. Or you want to break now or later after this subtopic? Because we will cover on still on simple calculation for what we call for the amount of cash required.
Continue. I think you continue.
Continue. Okay. All right. So I continue to this project crashing, especially the assumption. All right. So basically, for the purpose of project crashing, we need to understand several what we call several term. Okay, which is commonly known as cost loop. Okay, cost loop. Later on, we will apply this cost loop to the steps how we want to crash or compress a specific activities. Okay, so basically, what we call, there is as we can see here, we have cost here, right? And we have cost versus time graph. So basically, there is a linear relationship of activity duration and direct cost. So it will be what we call linear relationship. However, in the in the actual conditions, it is not really in straight line. Okay, basically it will have this curve line between these two, what we call between these two component of cost and time. So basically this is an actual relationship. However, we consider for the purpose of what we call for the purpose of our study as the what we call ni memang dia punya fundamental lah. Dia kira consider the close approximation. So we consider this straight line for the linear relationship. Okay, this dotted red colored ni line. Okay, for the cost loop. Alright. Okay, for the cost loop itself, the second thing is that apart from this graph, apart from this cost time relationship, we need to know, this one is the first item, we need to know the equation of cost loop. Okay, so basically, for the equation of cost loop, there are four main components such as crash cost, normal cost, and we have CD, crash duration, and also normal duration. So the first two related to the cost and the other two related to the duration or time. Okay, as the relation of this component it is, okay, so that's why we have the crash cost, and also we need to have the crash duration, and also it is also the same for the normal condition where we have both normal cost and also normal duration. So we need to remember this. We have CC, NC, CD, and ND. So basically this is the equation for the cost loop. Okay, so later on, most of the time especially in your final assessment, there will be a question regarding this cost loop and also project crashing. So before you further prepare the crashing, sometimes you need to calculate first the cost loop. So that's why we need to utilize this equation. We need to apply this question. All right. No, the question, we need to apply this equation or formula. All right. So basically, cost loop is equal to crash cost minus the normal cost divided with the normal duration minus with the crash duration. So later on, I will share to all of you what's actually cost loop and when we need to do the calculation. Okay. Okay. The other assumption is that we need to bear in mind that some activities can be crashed or shortened while some of them cannot. Okay. This one we will look at on this later on, especially on the critical activities. All right. Okay, so basically these are the assumptions for the project crashing that we need to understand. Okay, so now we will cover on the what we call on the simple example for the sorry. Okay. Sorry. Okay. So we will go through to this example to calculate the cost loop. Okay, here we have, suppose activity A has a normal duration. Okay, just now I mentioned we need to have the ND normal duration of 10 days and can be shortened to the minimum limit of 6 days. So this one will be CD, crash duration. The other statement is that the cost of completing activity is 6,000. Okay, within normal duration of 10 days. But if it is to be completed within 4 days, the cost will be 10,000. Okay, so this one will be crash cost. Crash cost, so for sure this one will be normal cost. All right. So determine the cost loop. So basically this is just a straightforward question where you need to calculate the cost loop for activity A. You just directly apply the previous equation of CC minus NC. Okay, this one. Okay, this one. And divided with ND minus NC. Okay. Sorry. ND minus CD. Okay. So we can see here that we just
Sorry, I missed that. Could you say it again?
Sorry. Okay. So you just put all the amount here, all the duration, and at the end, we can get the cost loop for this activity A. So basically, we have the amount for per day. So basically, it's referring to how much how much the activity costs to be per day. Okay, per day. So this is the daily cost. So it costs about 667 per day to crash the duration of activity A. Okay, that's the meaning of cost loop. All right. For example, we try to crash this activity for 4 days. All right. So the total cost that need to be bear by the respective parties is about 667 times by 4 days. Okay. So we will have the final amount. So all of this will be applied to later calculation. Okay. So basically, that's how this cost loop works and how when it should be calculated and when will we use this cost loop. Okay, so basically it is directly related to the project crashing purposes. Okay. Okay, I think that's just the simple example for the cost loop calculation, because most of the time, most of the question for the purpose of cost loop calculation it is just a straightforward calculation. However, you need to properly remember this equation. Which amount or which item to be deducted to which one, and what item to be divided. Okay, as long as we apply the correct equation, so at the end you will able to obtain this cost loop. All right, so that's all regarding the cost loop. So before we proceed with the calculation and also how we want to prepare the project crashing, I will share to all of you regarding the steps of project crashing. Okay, because there are several steps that we need to follow or that we need to understand, so that later on it is easier for us to do the project crashing. Okay, so now okay, so basically this is the several steps. So basically here we have 6 steps for project crashing. All right, so by follow all of these steps, so it is easier for all of us to do the project crashing or compression. All right, first of all, once we have the situation or the condition of a normal project, normal project condition, so what we have to do, the first thing that we need to do is that we need to prepare the network diagram. Okay, so basically this network diagram has been covered by Mr. Rahim during the early lecture. Okay, so hopefully so far all of you are already familiar with different types of network diagrams. So basically we have AOA and also AON diagram, activity on arrow and also activity on node. All right, so basically both of the diagram can be used for the purpose of project crashing. Okay, first thing first that we need to determine is that we need to know the normal duration, which is ND, normal duration of that specific activities or specific project. And then after that, we also need to determine its critical path. Okay, so that's why we need to prepare this network diagram, because we try to obtain the normal duration of the project, and then we need to have this information for critical path, so that we clearly identify and also clearly determine which of the activities are on critical path. Okay, because as we know, critical path referring to the longest duration for that specific project. Okay, because there are several activities related to a project, and among all of the activities there should be a critical path which is represent the longest path or longest duration of that project. Okay, so later on we will go through the sample questions, so we can try to have more understanding of this step. All right. Okay, and then after we have clearly determined these two components of normal duration and also critical path, then we will move to the calculation of cost loop. As I mentioned just now, once you have the question, you have the situation, you need to calculate the cost loop, so that this cost loop will be included together into the network diagram. Okay, because based on this cost loop, we can determine which of the activities require the most cost if we crash the project. Okay, so again, regarding this cost slope, we need to calculate this cost slope using equation, okay, which comprise of 4 main items, which is normal cost, crash cost, and also we have normal duration and also crash duration. Okay, so we need to do the calculation. So at the end, we will have a cost slope. All right. So that's the second step or the second component for the sequence of project crashing. And then the third one we have in order for us to crash the activities. Okay, this one is basically where we start to crash the activities. We need to select critical activity with least cost slope. Okay, as I mentioned just now, for example, for the AOA or regardless AOA or AON diagram, for example, we have this kind of diagram, this kind of network. Okay, so as we can see here that we have what we call three activities or three paths of the relationship of the activity relationship. For example, we have A, B, C, D, and E. So in this case, based on these three paths, we need to, the first thing before this, we need to identify which of these paths are critical. So for example, for the purpose of example, ABC tends to be the critical path, for example, okay? So we need to select these critical activities with the least cost slope, because at certain situation or certain time there will be more than one critical activities. So for example, ABC are the ABC and AEC. AEC are the critical activity. So how we want to select these two, which one is the most optimum? We need to go for least cost slope, because cost slope, as I mentioned or as I shared just now, cost slope is the cost per day, which is the we need to bear the cost based on the daily basis. So the higher the cost slope, so the higher the total cost at the end of the project crashing. Okay, that's why we need to go for the least cost slope. Okay, for the third step of project crashing. And then after that, once we do the crashing activity, and we need to recheck the activity, because sometimes later on we can see this kind of situation. Why we need to do the recheck? Because sometimes there will be a situation where we will have more than one critical activities. Okay, maybe we can look for formation of second or third critical path. Usually in normal condition, we have only one critical path. However, due to some crashing of the project, the second or the third, maybe the third critical path may appear. So that's why we need to recheck the activities. All right. Okay. Once we have done the rechecking of the related activities, and then we go for the determination and calculation of new direct costs. Okay. So basically this one related to the direct cost calculation. Because at the end we need to show the new direct cost involved for the purpose of project crashing. Alright, so that will be the fifth step of this project crashing or project compression. And then for the last step, we have indirect cost, because for certain case, we need to deduct the indirect cost for the new total cost. So later on, I will also share the example for this related steps or sequence. Okay. So basically, this is the whole steps for us to apply in order to crash the project. Okay. All right. So now we will look at to the first example of project crashing. Okay. Basically, this is the network, which is AON. Okay. AON diagram, because the activity, sorry, this one is AOA. Okay, AOA. Activity on arrow diagram, because task A is located on this arrow for each activities. Okay, basically this is the normal condition before project has been crashed. Okay, so this is situation for the project before crashing. Okay, as we can see here that I have put several numbering here, which is number 1, 2, and 3, which is basically refer back to this step. Okay, we have this 1, 2, 3, 4, 5, and 6 for the step of project crashing. So basically, this is where number 1 appear, because by having this question, we need to know its normal cost or total cost. So basically, it refers to the NC. So later on, we will use this amount or this cost for the calculation of cost slope. Alright, so this is item number 1 or step number 1. Once we have determined this normal cost, okay, and then we need to determine also the critical path. Alright, so basically for this example, we have 3 tasks, which are task A, B, and C. So basically, task A is the critical path for this project. Why we have task A as the critical path? Anyone can relate on that? Why we have A as critical path instead of B and C? Any volunteer? Okay, can someone recall what's actually critical path is?
I think it has the
Any
longest
of you?
duration.
Yeah, that's right. Okay, thank you, Abdullahi. So basically, among these 3 tasks, task A will be the critical task because it consists of the longest duration of 10 days as compared to task B and task C. Okay, that's why critical path appear for this task A. Alright, so that will be the second. Okay, supposedly, oh sorry, that one should be the third. The first one, we need to identify or determine the normal cost and critical path. And then for the second one, we need to determine its cost loop. All right, this one, the second step. Okay, for the cost loop, as we can see here that in this bracket, it mentioned that 3 at 100 ringgit per day. So meaning that this is the total, what we call total days or maximum days that can be crashed, and this is the cost loop. All right, basically the cost loop for this project. Okay, that's the second step of the project crashing. And then the third one, we can select the critical activity with least cost loop. All right. So for this example, because we currently have only one critical path, so for sure, obviously, we will select this task A as critical path, and this task A will be crashed, okay, in terms of its duration, because it is initially critical. Okay, for the sample question. Okay, the next thing is that this is the situation where this project after crashing task A. So basically for the first step, we try to crash the project for 1 day. Okay. Just now initially it is the initial duration is about 10 days. So we try to crash for 1 day. Here we deduct 1 day, so it will be 9 days only. Alright, so what we can do is that now step number 4 appear here. If we refer back, we need to recheck the activity. That's actually refers to, okay, because we need to look for formation of extra or additional critical path. Okay, so now task A is already 9 days, which is the same with task B. The duration for task B, which is also 9 days. So that's why now we have two critical paths here. All right. And then for item number 5, we need to calculate the total new cost. Okay, even we have to do the crashing only for 1 day. However, we need to calculate the new total cost. All right. So as it stated here, if we refer back to this cost load, the cost to be bear is 100 per day. If we meaning that if we crash for 1 day, so we will need to bear for another additional 100. So that's why we have this additional one, because the normal one is 5,000, right? And then if we crash for 1 day, we have this additional cost here. So that's why number 5 item refer to the determine and calculate the new direct cost. Okay, so here we have the new direct cost or the new total cost here. Okay, and that's this is the situation, the view when we have crashed the task A for 1 day. And then we will continue. We try to crash more. Okay, because we are trying to select the best or optimum condition of project crashing. Okay, the next one we try to go for 2 days crashing. Okay, as I mentioned just now, once we have crashed task A for 1 day, it seems like we have two what we call two critical path. All right, so the total duration is 9 days. Okay, because for your information, all of this project crashing is a try and error method. Okay, it's depending on our selection and on our creativity on how to go for the best and optimum level, what we call optimum condition. Okay, so later on there will be various output lah among the project planner or anyone who in charge on this crashing part. So for example, person A will come up with the certain amount which is differ from person B, okay, because it is depending on the own choice, okay, own selection. Okay, so there will be no specific ataupun accurate amount. Okay, there will be a range of the final output nanti. Okay. The second thing is that we try to crash both task A and task B. Okay, even though kat sini dia ada different cost load, however we try to go for both crashing for these two activities A and B, and it is by 2 days. Alright. Okay, kalau kita, if we crash both activities, task A and task B, which is previously critical or initially critical, and now task B is also critical. So we try to crash both activities. Okay. Okay, in order for you to continue the crashing activities, you just repeat the same steps or sequence. Okay. As I shared just now, we have several steps of project crashing. So basically, project crashing is about how we repeat the same procedure or the same step. So at the end, we are able to come with the optimum solution lah, optimum target. Okay. So here, project after crashing task A and task B for 2 days. So this is the new view or new situation, because for task A, if we reduce for 2 days, so the balance or remaining times that allowable to be crashed is only 1 day, and the duration will be 8 days. All right. Similarly to the task B, when we crash for 1 day, the new duration to complete this task B is also 8 days. And then once we crash both activities, we need to calculate the new total cost, which is repeat the previous step. Okay, for the new total cost, this 200 referring to crashing of task A. Okay, refer to its cost loop here, and then 75 refers to task B. So this 275 is the new additional cost that need to be added to this normal cost, previously normal cost. So the new total cost will be here, will be this amount, 5,275. Okay, so as you can see, as we crash more activities, as we crash what we call more option, the cost so far is increasing. Okay. All right. So before I proceed, is everything okay? Clear ke? Anything to ask? Because this project crashing is one of the ni lah kira antara soalan yang common dan juga akan ada will be in your final assessment. So basically, once you understand all of the step, it is easier to do the crashing. Okay. Okay ke semua?
So far so good, Doctor.
Alright, okay. So I will continue to the next one. So basically, we just repeating the same or similar step. And then the next one, okay. Since all of these, as we can see here, all of these tasks are now critical path, task A, B, and C. So supposedly this also right arrow. Okay. So we try to compress all of the tasks, okay, by 3 days. Okay. So what happened here is that you just repeat the same activities. Why we go for 3 days? Because you can see that the maximum or the allowable duration to be crashed for activity A, B, and also C, it is only 3 days. So if we crash for 3 days, it is already reached the limit for activity A. So at the most, we can go only for 3 days. Okay, especially for task A, because it is what we call, it is the initially critical activities. All right, similarly, we can repeat the same step. Here, this is the what we call, these three are the new cost for task A and task B, and this one the additional cost for task C. Okay, So TASI. So this one of the this is the cost for the previous crash condition. That will be contribute to this one 275, and 100 refer to this task B because we crash one more day for task B, and this one for task C. Before, because we also crash additional one day here, task C. Sorry, this is 75 for task B, this one for task A, sorry. A, B, and C. So at the end, this is the new total cost. Okay, new total cost for this project condition after it has been crashed. Okay, this is the new total cost, which is slightly higher than the previous one. Previously, if we crash only these two activities, task A and B, for today's the cost is about 5,275. However, if we crash all of these activities, the cost is slightly increased. Okay, and it turns out about 5,500. Okay, so at the end, basically this is the summary for the project crashing. So basically for this case is we can see the normal what we call the normal condition of the project with the total cost of 5,000. However, if we crash the project, it will increase the cost. Okay, and if we further crash the project, it will be further increase in terms of its cost. So if there is still need ataupun it is essential, it is required for the contractor to do some crashing, maybe they can go up until this one or maybe this one. Because as they go further, they will need to bear additional cost. Okay, that's basically the summary of this sample question for the project crashing. Okay, so by having this kind of view, we can choose, it's depending on the scope ataupun budget tu sendiri macam mana. So we can choose the optimum option. Okay. And then the next one, I will continue with maybe the second sample question. Okay, example 2. Okay, so basically most of the time, this is the view, this is the dia punya rupa soalan tu sendiri, the view of your question. So basically you will be given the information in this kind of table, which consists of different types of related activities to that certain project, and then you will be given the duration and for sure the cost. Alright, so another information is that with this asterisk remark, it refers to the critical path activities. So by having all of this information, all of this marking, so later on it is easier for you to prepare the network diagram where you already know that B, C, D, and E are the critical activities which contribute to the critical path. All right. And then the other one is assumption. Okay, so basically assumption is related to indirect cost of the project. For the purpose of this example 2, it's only about 50 ringgit per day. So at the end, later on, I will show this where should we include the calculation of indirect cost. Okay. This is the question in overall. Okay, so what you need to do is that you first thing first, for the first step, okay, the first step, if we recall back, we need to determine the total cost. Okay, for you to determine total cost, you just add up all the NC. This is basically NC, normal cost of all of the activities. So then you will have this total cost. All right. And then the other thing is that you need to determine critical path. So as mentioned here, B, C, D, E are the activities for critical path. And then how about the project duration? So basically, you will obtain this project duration once you draw the network diagram. Okay. So now, okay, before that, the other thing is that, so basically, this is the, sorry, up to this, and activity until to this row, and until to this column here is the original table. So you just need to calculate, you just need to add this total cost calculation or row or space for this calculation, and then you need to add up this column for total slope, cost slope. Okay, so you just apply the equation, the previously stated equation for the cost slope calculation, because all of this information for cost slope will need to be included in the network diagram. Okay. Once you have done this, you just proceed to the preparation of network diagram. Okay, so basically, this example is just straightforward. So what you have, you need to do here is that you just draw either AOA or AON diagram. So basically, this one is AOA. All right, so we have activity 1, B, C, D, E until F. So here we have A, B, C, D, E, and F. And you need to allocate each of these task name. For example here, B. And 20, refer back to this. B is normal duration. You just put the normal duration. And then, sorry, 5 as 5, 10, and so, sorry. Okay, this one is basically, okay, sorry. This diagram is also given for you because it's already state the what we call this duration for each activity. Okay, this one. For example, B we have okay, sorry for a while. C. Okay. Now if we refer back to this diagram, B is the normal duration, and then actually this one is CD. Sorry for the confusion. All right, so CD at this cost loop. Okay, all of these information are extracted from this table. How we calculate the crash duration? We just need to do the deduction here. 120 minus with 100. So you will be obtain the 20 for activity A. Okay, if you look at that, look at here, 20, and B is 5 because 20 minus 15, and it will be 5. Okay, so that's how we include all of the information to this diagram. Okay, and similarly to the cost loop for each activity, we just refer back to this table, the the what we call right hand side column or the final column. Okay, we just put all of this amount to this network. Okay, once we have this, we need to highlight the critical path, and then the other thing is that once everything are ready in this form, we need to calculate the total cost. Okay, so that's why as I shared previously, we need to always remember total cost is equal to direct cost plus indirect cost. So that's why we need to do calculation to find this total cost. So what we have here is that direct cost already obtained from here. This is actually direct cost, 48,300, and we need to add with the indirect cost. For this case, indirect cost, it is given in the question. We just assume that it is 50 ringgit per day. So in this situation, we have the total days is 140. Then we need to times with the total duration. So that's why we have this multiplication here. And at the end, this is the total cost. Okay. So that's the difference between the first example and the second example. Because the second example, we have the inclusion of indirect costs. Okay, so that's why we need to include it together to the calculation. And then the next one, so basically overall, this is how the condition of the network and also the condition of activities for this project before crashing, which is it is currently in normal condition. All right. So once we have done all of this, we will proceed to the next step to crash the activities. Okay. For this step, we try to crash activity D since because if we refer back, critical activities B, C, D, and E. So as we can see here that B, C, D, and E, all of these are on the critical path and they are critical activities. Okay, for this example, we choose to crash D first because D is contribute to the least cost loop, which is only 60 ringgit as compared to B 200, C 600, and also E 120. Okay, so basically it is obviously that we can choose from here. So priority for us to select the least cost loop activities, which is D. Okay, that's why we crash D first as compared to other activities. Okay, we proceed to crashing the D. And for this case, we go kita terus crash for 10 days. Okay, because the maximum crash duration is 10 days. So once we crash 10 days, it becomes 0. And then the new what we call the new duration, it will be here 80, and at the end the final one will reduce for 10 days, which will be 130 days. Okay, so what's the impact of this crashing of activity D? So we need to do the calculation, repeat the same steps to do the recalculation of total cost. Okay, so just apply of the previous amount for this total cost, just bring forward. Okay, this one, 55,300, and we need to add with the cost loop that need to be bear for each days for each crash duration. So here we have 10 days crash duration, so times with the daily rate, and then what we call this one is addition. However, we need to bear in mind that if we refer back to the previous table that I have shared previously, basically indirect costs, what we call indirect costs will decrease as the duration being shortened. Maksudnya lagi pendek masa, maksudnya kita dah crash that certain duration, so for sure indirect cost akan reduce lah. So that's why we need to do the deduction here. Once we have the total cost, maksudnya new one, we need to again deduct here. For how many days? 10 days, because the same we have crash this 10 days duration. So at the end, this is the total. The total cost for this situation after we crash the activity D. Okay. So similarly, because I already mentioned that crashing of these activities, we will always repeat the similar and also the same step. So we can try any activity that is potentially to be crashed. Okay. At the end, we can achieve the optimum cost. Okay. So far, okay kan? Before I show the rest of the crashing activities. Okay ke semua? Anyone? All of you?
So far, so good.
Okay, thank you. All right, and then similarly, we try to compress or we try to crash another, what we call another activities. And for this time, we try to crash activity E. And again, why we choose E? Because as compared to B and C, the rest of the activities on this critical path, what we call it has the lower cost slope, which is 120 as compared to 200 and 600. Okay, again, just repeating the same steps or same method. We have another additional crash duration. So this time we crash this activity E, we mean that we try to totally crash this duration, which is also for 10 days. So at the end, the new duration will be about 120 days. So again, we just use the latest total cost and just bring forward here. And then we need to add with the cost slope of that respected ataupun yang selected activities, this one. So for this cost E, the cost slope is 120, need to times by 10 because it is 10 days crashing. And we come out with this new amount. And do not forget to deduct with the IC, indirect cost. Okay. Similarly for 10 days. And at the end, we have the new cost here, the new total cost. Okay, so basically this is the repetitive activities. Okay, and if we try to, okay, if we can see here that the, what we call, the currently all of these activities become critical. Because A also become critical is because previously it is 120 days, the total duration, which is become the same with this critical path or previous critical path. And also similar to the F activities, it's currently on the critical path. Okay, so the next one we try to crash. Previously we have D and E. Now we try to crash B, A and B. Okay, this one we have A and B. Because A and B quite lower in terms of its cost slope here and here as compared to C and F. Because C if 600, F if is 300. Okay, so all of the selection, all of the apa orang panggil pilihan untuk kita crash pilihan activity tu depending on our ni lah apa on selection, because at the end different person ataupun different apa parties tu akan come out with a range of the project crashing amount lah. Sebab dia tak ada macam, sebab certain orang akan pilih apa orang kata, maybe dia akan reduce for this case maybe A only, and later dia akan again continue to further crash B. Okay, for this case we try to add another crash activities A and B. Okay, similarly, we just continue with the recalculation of total cost, and at the end, this is the new cost, which is if we notice that the cost is become more and more higher as compared to the first one. We have 55,300, and then it's become higher, it increasing another 100, and then 55,400, and now it become 56,000. And the latest one, if we crash more, it will be increasing more, which is about 57,350,000. Okay, all right. And then if we try to crash everything, okay, we try to crash all of the activities. Okay, this is the early stage. We have crash. We have DNE have been crashed, and then plus A and B, and now we have another set of activities that have been crashed, A, C, and F, because A, we try to reduce more in terms of it crash duration. So that's why for the latest condition, we have this additional one. So similarly, we refer to the previous total cost, just bring forward to this one. And then 600 times 5 for activity C, 300 for activity F. And then we have 100 times 5 for activity A. Okay, that's why we have ACF here, ACF. And at the end, we need to deduct with the IC, indirect cost. How many days? Depending on this one, crash duration. Okay, for example here, 15 reduced to 10, so meaning that we have 5 days crash duration. So that's why we have time with 5. And at the end, this is the new total cost. All right. Again, if we continue to crash again until if we try to explore, or we try to project what happened if we add more crash, do more crashing, what happened to the cost. Okay, we can just to try and error. However, if we can see here that the cost is increasing, 62,100 become now 66 with 66,840, this one. Okay, so basically I just want to visualize, and I just want to share how actually this project crashing work. Okay, so at the end, if we can see here that similarly, we can plot the graph based on our crashing activities. So basically, this is the original cost, total cost. So for example here, the original duration is 100. What we use, the budget is still acceptable, because if we do another days, okay, then there will be increment for about 1,000 here, okay, and so on. So by having this view, by having this plotting, so we can choose which one is the optimum depending on our capacity and specific scope of the project. So if we able to bear the cost, maybe we can choose this one, or maybe we can stop until here, just until here, with the 10 days reduction or 10 days crash duration. Okay, all right. So I think that's all the and now the last part is overview of sample question. All right. So similarly to project cash flow, So I have provided several sample questions. Sample question 1, 2, maybe until 3. Okay. So basically, these 3 sample questions are the examples for today's class. Alright. Okay. If we go through this sample question, so basically, sample question 1 is just straightforward question, because what you need to do is that you need to calculate the direct cost flow for this construction activities. So basically, this is just a straightforward cost flow. You just need to what we call need to include the 4 elements of NC, CC, and also ND and CD. Okay, you just put all of these what we call all of these information to the equation, and then at the end you can come out with this amount. All right, later on you can try to go through all of this question and do your own practice, and if you have anything to ask, you may ask me. Okay, I will try to help all of you. All right, so this is just a simple question for the cost loop calculation. And the next one, example of project crashing. Okay, so basically this is just similar to our example number 2. You have given activity, time, and also cost. All right. So basically, once you have this question, all right. Okay, this is continuation statement. Okay, it is given that indirect cost per day is 250. So later on need to kira, sebab soalan ni memerlukan kita kira calculate the indirect cost of the project. Okay, so berapa sebenarnya the whole direct cost per project. So how we want to calculate this? Okay, you need to know daripada sini, you need to what you need to do is that one, as I mentioned previously, you need to calculate the normal cost. Second thing, you need to calculate the cost loop. And then third one, you need to know the dia punya crash duration, CD. You just minus the 7 days with 3 days. So basically 4 days of crash duration here. Alright, so you calculate all of this, determine all of this figure, ataupun dia punya berapalah jumlah dia, and then based on this, transform to network diagram. Okay, based on network diagram, and you will obtain the total duration. Okay, duration how many days? Okay, how many days here? At the end, you boleh times berapa hari that need to be times with this that need to be multiplied with this given indirect cost. Okay, so basically I have provided the answer, so you may do your own calculation, try to answer this sample question and check with this given given answer. For the question B, it require you to determine the activity indicate the lowest if time need to be done for the project. Okay, so basically it refers to the lowest what we call lowest cost loop. Okay, so you need to just calculate, and then okay, basically first soalan, especially for the final exam, what you have to do that is already given which that you need to, and you will come out with the same figure lah, same amount. Okay, so activity need to crash, so at the end you need to calculate the total cost, new total cost. So basically these are the sample questions for project crashing. Similarly to this one, table 3, for the sample question 3, these are the example that you need to answer. You need to do the calculation. So based on the given assumption, given statement, okay, later on all of this I think that's all. So later on you may do your own practice or do your own calculation by answering this sample question. Alright. Okay, so anything to ask? Okay, ke semua? Because of the question. Is it okay, everyone?
Okay.
Okay. Alright. So I think for our morning session, we will stop up until here, and then we will come back later on around 2:30 for the next topic of project monitoring and controlling. So thank you and Assalamualaikum.